Today we are going to build a 3 to 8 decoder using the Logism, and we are going to use with the 3 to 8 decoder. We have to have 3 selectors, which is the input, and then 8 output. We'll use both the AND gate and the OR gate. So as you can see, we have our gate. So you click on your gate. So we'll use the AND gate and then the NOT gate, and then we'll connect it to the LED to test our decoder. You can see we've selected our 8 AND gate, which is our 8 output. So we'll go ahead and select our 3 input, which is the OR gate. We've selected our NOT gate. From my previous video, if you watch how we build a multiplexer, so you already know how to do the selections and how we'll connect the lines. So we've selected our NOT gate and then our 3 inputs. We'll then go ahead and select the LEDs, which will indicate the function of the decoder. So as you can see, we are still on connecting the lines. So we also don't forget the truth table. So we'll use the truth table to connect all the lines. You can see that from the AND gate to the LED is red because we've not connected it. So we'll connect those lines to the NOT gate, and then we'll put in our 3 inputs to see, and we'll then go ahead and label them too. Then we can see how best our decoder 3 to 8 decoder will function. See, we've wonderfully labeled all the NOT gates, that's the 3 inputs, and then we've also labeled the 8 outputs. So the 8 output is from Y0 to Y7, and then the 3 input is A, B, and C. So we don't forget the truth table. We'll use the truth table. So you can see that from the truth table, A will be 0, B will be 0, C2 will be 0. That's from the first AND gate connecting to the lines, that's the Y's. So we are quickly going to do that. You can see that as you are connecting the lines, the LED is indicating now it's changing from red to dark red because you are using the truth table. So take note of that. You can see we are done connecting the lines, wires, and everything is perfectly correctly done. So you can see from the truth table, the Y0 is 0, 0, 0, as you can see, and then the Y1 is 1, 0, 0. So we use the dark green as the 1, and then we use the light green as the 1, and then the dark green as the 0. So, and you make sure you follow the truth table. So the Y2 is 0, 1, 0, as is indicated on the line. And thank you for watching the 3 to 8 decoder. So we are randomly going to change the numbers to see how our LED will behave. So once I change, here to that's the A, to 1 and then the B to 1, you can see that the Y1 LED is on. And when I change it to 111, that is the LED for Y0, because from its logic it is 111. So you can see it's on. When I change to 110, the Y0 on, because from the truth table is 011, as you can see. So when I change to 101, we expect the Y2 to on. So you can see the Y2 LED is on. I can go ahead to make it 001 and Y4 will turn on. 001 and the Y6 rather turn on. But that means that we might have some error, and we will cross check to see what the error is. There is an error at the Y6 because from the truth table it's supposed to be 010. That's why you can say when you do it 001, the Y6 on. So we change the input to make it the 001. So it's supposed to be 001. So it's supposed to be 0011. It's supposed to be 011. So we connect it, and so let's see how it behaves. Let's hold on. So once you do it 0, once you do it 0, 1, 1, let's do the 0, 1, 1, and Y4 ons. Okay, so 0, 101, 101 from the truth table, you can see that the Y2 ons, and ons it goes. So thank you for watching multiplexer 011 and so 110. So 11. Thank you very much for watching our decoder.